Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of important questions of coordinate geometry. For this lecture, I am using the work of one of my best student, Ms. Bisma Sami, of class 2021, the Lyceum. An important advice for me and for everyone: be of benefit to others. Question number 1. The diagram shows a rectangle ABCD. The point A is 0, -2, C is 12 and 14. The diagonal BD is parallel to x-axis. This line or this diagonal is parallel to x-axis. So if any line is parallel to x-axis, then its equation is y is equal to C. This is the equation of horizontal line. This means every point on this line have same y-intercept. Part 1. Explain why the y-coordinate of D is 6. For that, we first need to find the midpoint of AC, because in rectangle, the midpoints of diagonals are same. The midpoint of AC is 6, 6. Since this line is horizontal and its equation is y is equal to C, and this is 6, we just have found this. So every point on this line have same y-intercept, have same y-coordinate, which is 6. So the y-coordinate of D is 6 and the y-coordinate of B is also 6. This is here. The midpoint of AC lies on BD, and as this is very simple, the equation of this line is 6, then all points on it have same y-coordinate, that is 6. Number 2, the x-coordinate of D is h. This is h. Express the gradients of AD and CD in terms of h. So this is so simple. We have A, we have D, we can easily find the gradient of AD, which is 8 upon h. We have C, we have D, so we can easily find the gradient of CD as well, which is 8 upon 12 minus h. Part 3. Calculate the x-coordinates of D and B. The x-coordinate of D is h and the x-coordinate of B is x. For the x-coordinate of D and B, we need to use gradients of these two lines. You know, this is rectangle, so this angle is 90, therefore these two lines are perpendicular, and hence the product of their gradient must be -1. This is the formula of gradient of perpendicular lines. M1 times M2 is -1. So with the help of this formula, we can get the value of h, which is 16. So for D, since D is on right side of the origin, so h should be 16. And the other value of h will be the x-coordinate of B. The x-coordinate of B should be -4. So with the help of this formula, we have found the x-coordinates of D and B. Number 4, we need area of ABCD. For this part, we have two options. We can either use this formula for area, or we can use this formula for area. Length into width into 2. AB, CD or AB I mean, we can get the lengths of these two sides, and then we just need to add these two lengths and then multiply answer by 2. So we have this option and we have this option. This option is easy. So for the area of ABCD, we need to write A here, B here, C, D, and A is repeated according to the formula. So you all know how to multiply these things. I discussed these things in my first lecture of coordinate geometry. We multiply these numbers in this way, and then we multiply in this way. So when you will solve this, you will get this thing. This modulus is to make the negative sign positive. So this is negative, so this modulus will convert negative into positive. So we have 320. Finally, we have 160. You can check the solution again. Question number 2. The diagram shows a triangle ABC. This is the triangle ABC. A is given, B is also given. The gradients of AB, AC and BC are 2m. The gradient of AB is 2m. Gradient of AC is minus 2m, and gradient of BC is m, which is here, where m is a positive constant. Number 1, find the gradient of AB and deduce the value of m. We have the coordinates of A and B, so we can easily find the gradient of AB, which is 2. Now we need to equate this gradient with this 2m, which is the gradient of AB. So the value of m is 1. Now, since we have found the value of m, therefore we can easily find the gradient of AC and CB. Therefore, by substituting plus 1 here, we can get the gradient of AC, which is minus 2, and gradient of CB is m, so it's 1. Now we need coordinates of C. Well, C is the point of intersection of this line and this line. For that, we need to find the equations of these two lines first. So this is the equation of BC. We have the coordinates of B, we have the gradient BC, so we can get the equation of BC. And this is the equation of AC. By solving these two equations simultaneously, we can get the coordinates of C. Last part. The perpendicular bisector of AB. This is the perpendicular bisector AB. This line is AB. So perpendicular bisector means a line which divides another line into equal parts and makes 90 degree with that line. So this is the perpendicular bisector of AB. So this is the midpoint. Of AB. So if I ask you find the equation of this bisector, you should find the coordinates of midpoint first of AB, and then you need to get the gradient of this bisector with the help of the gradient of this line AB. So coordinates of midpoint are 9 and 10. And its gradient must be minus half, because gradient of AB is 2, therefore gradient of bisector must be minus half. Now we can easily find the equation of this bisector with the help of this midpoint and this gradient. Here is the equation of this bisector. Now the perpendicular bisector of AB, we have found the equation of this bisector, meets BC at D. Now this bisector intersects BC at D. Therefore, for the coordinates of D, we need to solve equation of this bisector with the equation of line BC, because D is the point of intersection of these two lines. So by solving equation of this bisector with the equation of BC, we can get the coordinates of D. You can check the solution again. Next question, number 3. The diagram shows a rhombus ABCD in which A is this, C is this, and B lies on the y-axis. This means the coordinates of B must be 0, y. If any point lies on y-axis, its coordinates must be 0, y. X coordinate must be 0. Number 1. Find the equation of the perpendicular bisector of AC. This is AC and its bisector is diagonal BD. This is the perpendicular bisector of AC. Well, since the midpoints of the diagonals are same in rhombus, therefore we can get the coordinates of midpoint of AC, which will help us to find the equation of this bisector. So the coordinates of midpoint of AC are 2, 3. Now we have the coordinates of midpoint which lies on BD as well. Now we need gradient of AC. The gradient of AC is 1/3. Now with the help of this gradient, we can get the gradient of this bisector. It should be -3 because bisector is perpendicular to AC. Now we can easily get the equation of this line BD because we have the coordinates of of the point which lies on BD, and we have the gradient of BD. So with the help of this gradient and this point, we can get the equation of this bisector. Now we need the coordinates of B and D. For B, see, B lies on this bisector. So for B, we need to substitute x0 into equation of perpendicular bisector or equation of BD. So for the coordinates of B, we need to substitute this point into equation of BD, which is this. So by substituting 0 here, we can have the coordinates of B. The coordinates of B are 0, 9. Now we need the coordinates of D. Listen, we have discussed this in first lecture of coordinate geometry, that if one vertex is unknown, 3 known and 1 is unknown, so always use this formula to get the coordinates of that point, because midpoints of diagonals are same. So with the help of this formula, we can get the coordinates of D. We can assume the coordinates of D as x, y. So we use this formula here. Midpoint of AC is equal to midpoint of BD. This is the way to get the coordinates of D. Area of rhombus, this is so simple. We can use this formula and get the area. So this is A, this is B, this is C, this is D, and this is A. Let me explain you how to simplify these things, how to solve this. So number 1, multiply this with this, this with this, this with this, and this with this. So -9, 0, 5 3s are -15, 4 2s are 8. Then put negative sign and then multiply in this way. 2 0 0. 9 times 5 makes 45. Then 4 times 4 makes 16, and 3 1s are 3. when you will simplify this, you will get minus 80, and this modulus converts negative into positive. So final answer is 40. So this is the way to simplify this thing. This is the way. I'm leaving this question. This question is very simple. We just need the coordinates of A and B. So by solving these two equations simultaneously, we can get the coordinates of A and B, and then we need length of AB and midpoint of AB. This question is simple, so I'm leaving this. You can check the solution if you want. Question number 5. Points A, B, C have coordinates. Find the coordinates of the midpoint AB. This is simple. You can do this yourself. Find the equation of the line through C. Through C means passes through C. Perpendicular to AB means like this. Now you have to use this point and gradient of AB. First find gradient of AB and then take its inverse reciprocal to get the gradient of this line. So the gradient of this line is half, because gradient of AB is minus 2. This is a rough sketch. So after getting the gradient of this perpendicular line, use this point and this gradient and get the equation. Next question. The line L1 passes through the point 2,5. This is the rough sketch. This is A and B. This is B, and this line is L1. This line is L1 with A and passes through A and B. The line L2 is parallel to L1. This is L2. Both lines are parallel, so both have same gradient. And this L2 passes through origin. So we have the coordinates of A and B, so we can get the gradient of line L1, and that will be the gradient of line L2. So gradient of L1 is half. Therefore gradient of L2 is also half. L2 passes through origin, so we can get the equation of L2. The point C lies on L2 such that AC is perpendicular to L2. So C is here and AC is perpendicular to L2. Now we need the coordinates of AC. This is so simple. First get equation of L2, which is this. Use gradient of this line because both lines are parallel. So gradient of L2 is half, and this point is on L2 origin. So with the help of these two things, we can get the equation of L2. Now get the equation of AC. For that you need to use this point and inverse reciprocal of this gradient, which is minus 2. So use this point and this gradient and get the equation of line AC, which is this. By solving these two equations simultaneously, we can get the coordinates of C. Now we need distance AC, which is simple. By using distance formula, we can get the distance AC. See, this rough sketch help us to solve this question. So try to make rough sketches. Next question. This line, this is not clear here, but this is here. X upon A, Y upon B is equal to 1, where A and B are positive constants, meets the x-axis at P. This line meets the x-axis at P. So the coordinates of P must be x comma 0 and y-axis at Q, so 0 comma y. Given that distance PQ is under root 45 and gradient of PQ is minus half. So we have two very important informations. We have gradient of PQ and distance PQ. So we will form two equations. First we will find coordinates of P and Q. For coordinates of P, we need to put y0 here. When we will put y0 here, we'll get x is equal to a. See, this is here. So by substituting y0 here, we can get the coordinates of P. Let me make it simple. This is fine, but you can also do this in this way. You don't need to simplify this. You can directly substitute y0 here. See, for P, substitute y0. When you will put y0 here, you'll get this thing, x upon a, 0 upon b, 1. Therefore, x is a. So the coordinates of P will be a comma 0. Similarly, for the coordinates of Q, you should substitute x0 into equation of straight line PQ. So y is equal to b. Hence we have the coordinates of P and Q. Now form equation number 1 with the help of this information. Distance PQ is under root 45, and this will become a square plus b square. When you will remove square root, you'll get this equation. This is equation number 1. Now form equation number 2 with the help of gradient of PQ. When you will find gradient of these two, you'll get this thing. Equate this with minus half, and then this is equation number 2. By solving these two equations simultaneously, we can get the positive values of A and B. Make sure you give the answers, you give the positive values of A and B, because A and B are positive constants. Question number 10. Well, in this question we have coordinates of A, B, C, and it says diagonals intersect at M, and these two lengths are same. Calculate the coordinates of M and D. First we need coordinates of M. M is the point of intersection of line BD and line AC. So first find equations of these two lines, AC and BD. Well, these two lines are also perpendicular. So first get the gradient of AC. Gradient of AC is half. Therefore, gradient of BD will be minus 2. Gradient of this perpendicular line must be minus 2. Now find equation of AC. This is the equation of AC, and find equation of BM or BD. Now solve these two equations simultaneously for the coordinates of M. For D, use midpoint formula. Coordinates of D will be x comma y. Since M is the midpoint of B and D, therefore with the help of midpoint formula we can get the coordinates of D, which are 7 and minus 2. Now we need ratios AM and MC. We have three methods to solve this part. The first method is ratio method. If you want to use this method, you can. First find AM, then find MC, and then take their magnitudes and get the answer. And another method, which is the simplest way for ratios, is write A here, which is minus 1, then write M, This is a similar triangle method. I discussed this method in my first lecture of coordinate geometry. This method is very simple. And we need a C, so 9, 4. We need ratio AM and MC. So according to this method, you need to subtract either x coordinate or y coordinates of all these 3 points. So I am subtracting the y coordinates. See, I have to subtract the y coordinate of M from the y coordinate of A. So when you will subtract the y coordinate of M from the y coordinate of A, you will get this thing. -1, -2. Now subtract the y coordinate of M and C. So it should be 2 - 4. Do subtraction in this way. -1, -2, and then 2 - 4. You can also subtract the x coordinates in the same way if you want. So you'll get 3 upon 2, -3 upon -2, so which will become 3 upon 2. Hence the answer is 3:2. See, this method is very simple and short. So whenever they ask find the ratios, always use this method. You can understand this method well if you watch my first lecture of coordinate geometry. In this question, we just need the x coordinates of A and B. We just need to verify this equation. So A and B are the point of intersection of this line and this curve. So just equate these two. When you will equate these two, you will get this thing. This is here. Now you need to take x common. You will get this equation. By breaking the middle term, you will get the values of x. Let me show this working here. (2x power 4), 4x square minus x square minus 2. So by taking 2x square common, we have x square plus 2 here, minus 1, x square plus 2. So we have x is equal to plus minus 1 upon root 2, and this is invalid. That's the final answer. You have to show the working of breaking the middle term. Well, this question is simple, so I am leaving this question. I will only discuss the important questions now. This question is also a simple question. Let me just explain the concept. We need the equation of BC. So first we will find gradient of AB, which is 2, and with the help of this gradient we will get the gradient of BC, which will be -1/2. We have gradient, we have point, we can get the equation, which is this. Now we need coordinates of C. For that we need to find equation of this line AX, and when we will solve this equation with equation of BC, we will get the coordinates of C. So this is also very simple. This question is very important. Well, question number 18. The point R is the reflection of the point. You can suppose this point as A, So the point R is the reflection of the point A in this line. When something is reflected, then its distance from the line of reflection should be same. Like it's the distance of the point and its image should be same, because line of reflection is the mirror and we get mirror images when we reflect anything. So these two distances are same. Distance of this point A to this line is exactly same as the distance of its image R from this line. In reflection, distance of object to the line of reflection and distance of image to the line of reflection both are same. In fact, line of reflection is the perpendicular bisector of object and image line. This line of reflection is the perpendicular bisector of line AR. So first we need to find the equation of find equation of this line AO. After finding the equation of this line AO, we will solve these two equations simultaneously. When we will solve these two equations simultaneously, we'll get the coordinates of midpoint. This is the midpoint. After getting the coordinates of midpoint, we can get the coordinates of R. So number one, for the coordinates of M, get the equation of line AM. For that, we need the gradient of this line. Gradient of this line is 3/2. By making y subject from this equation, we can have the gradient of this line, which is 3/2. Gradient of this line is 3/2. Therefore, gradient of AM will be -2/3. Now we can get the equation of AM. This is the equation of AM. By solving this equation with the equation of AM, we can get the coordinates of M. Hence, the coordinates of M are 3, 9. Now, M is the midpoint of AR. So with the help of midpoint formula, we can get the coordinates of R. See, 3, 9, and this is here. So remember one thing, that the distance of object to the line of reflection is equal to the distance of the image to the line of reflection. This point is midpoint and line of reflection is the perpendicular bisector of this AR. You can take the screenshot of this solution if you want, because this question is important. Next question, number 19. Well, first we need coordinates of x. For that, we need to find equation of CX and AB. Equation of AB is this. We have the gradient of AB, therefore we can get the gradient of CX. Gradient of CX will be 3/2 because CX is perpendicular to AB. Now this is the equation of CX. By solving these two equations simultaneously, we can get the coordinates of x. Now the last part of this question, we need ratios AX and XB. Now use the method which I already have discussed earlier in this lecture, that write the coordinates of A, X and B in this way. We need AX and XB, so write AX and XB in this way. Now either subtract the y coordinates of both in this way or x coordinate of both in this way. So 14 minus 8 is here, and y coordinate of x is 8, and y coordinate of b is this. So 8 minus 6. When you will simplify this, you'll get the ratio 3:1. You can also solve this question by subtracting the x coordinates of these two. So 2 minus 11 is here, 11 minus 14 is here. The answer is 3:1. This is the last question of this lecture. I hope this lecture will help you to understand the solutions of the coordinate geometry questions. Good luck and Allah Hafiz.